Okay, so what we're doing here is we're going to look at intro into databases, which is what this is. So most of you probably have some experience with databases, but when we think about databases, we can sort of think about data. Data could come in many formats. If we thought about what the data was in a phone book, or what the data was in a Excel spreadsheet, or what the data was in a file cabinet, or what the data was in your head, or data on Twitter, right? Basically, what we're looking at here is that some data is persistent and some data is accessible, right? Not always the same thing, right? We could see that, data within take a couple of examples here. Data that's in our phone book, right? It can be persistent, but how accessible is it in terms of getting the data? Well, it depends on what data is that you're looking for, right? It's pretty good if it's alphabetical. You could end up finding it pretty easily. As opposed to if you ended up looking at data on a spreadsheet or data in a Twitter application, it's going to be much easier to get access to. So we've got hashes and arrays have data as well. So what's the great thing about this? Well, the bottom line really is that, before you ended up having relational databases, every application had their own way of storing data. And so every application had files and you were persisting the data, but the way that you ended up persisting the data in one file was different than the way you would end up persisting data in other files. Every time you had a new application, you might say, hey, look, I'm putting my data in this file, and I'm putting my users in this file, I'm putting my departments in this file, and here's the way that I'm going to format it in this file, and here's the way I'm going to format it in this file, and it was really a mess. So you could get things working with one application, but it was very difficult, right? There wasn't some central way or some agreed upon way to handle data. So what you ended up having instead was you had these database management systems, and these database management systems basically allowed you to have separate applications that were accessing the database. And again, some of this was sold as, hey, non-tech people could access the data, but if you were a non-tech person, exactly how much serious SQL you could write might be, somewhat debatable. When we end up thinking about this database, and you saw this, is that we have this idea of a primary key. We have our data, which are in tables. These tables have columns. They're also called attributes. Sometimes you'll see rows as referring to instances or either tuples or tuples. We see that duplicate rows are not allowed. What does that mean? Well, you saw the example with, you could have two users with the same mo, but they couldn't have the same primary key. They couldn't have the same ID. So SQL is an agreed upon syntax for interacting with the database. And there's different databases that end up implementing SQL, but SQL is the standard. Sometimes they implement the SQL a little bit differently, which can be a little bit of a drag to work with, but a lot of the common things tend to be the same. So again, you could sort of think about SQL as an agreed upon language for interacting with a database. Hey, look, you could make a proprietary database that doesn't use SQL, but then people are going to complain, hey, look, how come this doesn't work like SQL? So the commands that you end up using for interacting with a database, you could end up inserting, right? If we think about CRUD, you could end up inserting, you could end up selecting, which is like reading, you could end up updating, you could end up deleting. You also have the ability of creating new tables and new views and basically modifying the schema.
What's a view?
A view is just another form of a table, and that's about the most that I could give you because they're kind of frowned upon, and I haven't used a view in a database in a long time. I would imagine if you are maybe a Microsoft SQL Server guy and you're accessing data in a certain way, it might make the accessing of that data a little bit easier. I think in some respects now it's actually coming back to me as I'm talking to you. It's sort of like a virtual table. It's not really a table that ends up existing, but you're sort of recreating the table to make it faster to access data. Not terribly important for what we're looking at this point. So one of the things that you have with databases is whether or not a database. One of the things that you have with relational databases that you don't have with other databases is this whole idea of consistency. So, I mean, this comes up a lot where you sort of would be dealing with things like a banking application where a withdrawal from one account is going to end up turning into a deposit from the other account. Or the idea, if someone has $100 in their bank account and, they end up, getting 2 ATM cards, or they're logged into their account and they're there with their ATM card and they hit the withdrawal really fast, that they'll be able to get two withdrawals. This is sort of what you're sort of guarding against, and using a relational database helps out with this, doesn't necessarily solve all the problems. One of the things that you sort of look for here is the idea of, hey, look, if the database ended up crashing in the middle of a transaction, what ends up happening? So again, someone's decided to transfer money from an account, and so you're pulling money out of one account and you're adding it to another. What ends up happening? These are things you could end up looking at. In most applications, if you're not dealing with banking applications, this idea of transactions is not nearly as critical. But if you are dealing with an application with that type of critical data, you might be dealing with transactions in the database to basically make sure that you have a number of things that are happening, and either they all happen or none of them happen. So if you end up starting to withdraw money from an account and something crashes, you make sure that you don't modify that record on the account because you weren't able to go and transfer it somewhere else. So the whole idea of this is that you want the database to be transactional. Again, just what I sort of described before. And the other thing is that you also want the database to be consistent. So consistency is a little bit easier to deal with. That's something that you will deal with where, if you want a certain column to be a number, if you want that to be a number within a specific range, if you want to make sure that every department has a valid manager ID, these are things that you could deal with. And again, these all have to do with how you end up setting up your schema. I think what you're looking at here is that if you had a database and you just kept your data inside of a file, you'd end up running into issues because, again, if you're opening up that file, someone's reading from the file, someone's writing from the file, sort of doing your database management just from a file is going to be a little bit tricky. And that's one of the reasons why, instead of actually just putting data in a file where, let's say you had two different processes that were accessing a series of files, and one, and I'll use the word thread because, again, if something is happening asynchronously in Node, there are threads, you're just not accessing them. And here you could run into a situation where you have two different processes that are waiting for different files. And again, this is one of the reasons where you could think, hey, look, I don't really need a database. Let me just store things in a JSON file and I'll read from the file. This is not going to work for sort of any scalability from an application perspective. So databases are going to give you the ability to do this. So you can end up having persistence. But one of the things that you can end up getting the data from a database is the idea of actually having different tables and having relational tables. So as an example, if we have this idea of students and we have this idea of addresses. So a student, and in this case, all this really is, well, this actually, one of the things that this is doing here is that this is saying that a student has an address, okay? But an address can belong to multiple students, right? We see this idea with this address 2, and the address 2 is both for Nick and Andy, and there could possibly be an address here, address 3 that's not even represented in the database. This would be a little bit of a weird schema, but just an example of a schema. So, for an example, these are things that we looked at before. If we wanted to get an idea of all the students that are 20 years old, we could end up doing a select statement on this table, and we could do a where clause and basically find all the students that are of a certain age, right? And this would give us a subset of the data. So one of the things that you end up doing with the database is, running these queries to get the data that you're looking for. So one of the other things that we could do is that we could end up doing a join and say, hey, look, who are the students, with their addresses? In order to do this, and this is something we looked at before, where we would end up doing a join, and we would specify that the address of the student matches up with the address's ID. Now, I don't really like the naming convention here. I think what I would probably do on the students table is that column where you see address, I would call it address ID because that's really what it is, an address ID, and I think it would be a little bit easier to read. So here, this would end up giving us, a result of our students with addresses, and here we could end up doing a where clause, and maybe we just want to find the students that are in Chicago, and we could do where clause. So again, we have the students table, but we have to join on the other table to find out which students are in Chicago. Not exactly sure what this is supposed to be.
That select statement?
Yes.
Back there about Chicago?
Yep.
It was lowercase, and the database had uppercase. This is case sensitive, isn't it?
It shouldn't be case sensitive. SQL statements are not case sensitive.
Oh,
yeah. I should rephrase that. I mean, I think it sort of depends on the database engine, but I think for the most part they're not. You could test it out. I don't think it really is going to matter one way or the other. But some of the times what you'll end up seeing is that the keywords in the SQL statement are always capitalized, and the other ones are actually just the name of the tables and the name of the columns. So that's one of the things you'll end up seeing. Here's some cartoons. All right, here's a select statement. Right here, you could end up selecting based upon different criteria. You could also be destructive. You could end up dropping the people table. Here's another example that probably makes maybe a little bit more sense, where you have a student and you have a school, right? So now the combination of the student and school is going to end up giving you an enrollment. So you have a student ID, you have a school ID, and again, this enrollment table, we would call this a join table. So what this is telling you is that a student can have multiple enrollments, right? Or really what this ends up coming down to is that from this schema, a student can have multiple schools, right, through the enrollment table, and a school can have multiple students, again, through the enrollment table. Now, again, does that make sense? Well, it depends. You could have students that go into a school. Maybe they get transferred in a school. Probably a column for this that's kind of missing from the enrollment table might be the year of the enrollment, right? Because you might be interested in some sort of history of the students in terms of dealing with the enrollments. Another thing that you might have is even within a year, a student could get transferred. So possibly there's another column on the enrollment table called current that tells you whether or not that's the current enrollment. And we could have a business rule that says, hey, look, for a given year, a student can only have one current enrollment. Maybe they have no current enrollments. They ended up getting kicked out of school or that sort of thing. So again, this deals with the joins, right? One of the things that you're constantly doing is dealing with how these tables end up getting joined. So we take this situation together. Again, what we're looking at is that the school ID matches up to the school table. The student ID matches up to the enrollment table. One of the things that we would just see by looking at this is that nobody's enrolled at Simpson University. All of the students are enrolled, and there's actually 2 people that are enrolled at Springfield Elementary. These are all things that you can figure out by writing your queries, right? So one of the things that you'll see is inner join. You could get rid of inner join and just use join. And here you're able to join on these 2 tables. And so here, maybe you just are dealing with the enrollment for a particular school. So this would end up giving you the enrollment of different schools. When we think about these joinings, the sort of standard join is going to be the inner join. And this is something that Ilya was asking before. If you basically said, hey, look, I want all the records on the left. I don't care if there's a join on the right. Then you would end up doing a left join. Okay? As opposed to if you said, hey, look, I don't care what's happening on the left. I want to make sure I get all the records on the right. You'd end up doing a right join. The other one is an outer join. It's also called a Cartesian join. It gives you a boatload of records, and usually there's not much of a need for doing that unless you sort of wanted to generate data. Because if you did that, there really was absolutely no point of doing the join in the first place. So we could have this idea of we've got these pets and we've got these owners. So here we could specify a join table, right, where we have the pet's name and we have the owner's name. Again, this would be a little bit weird because we would probably want to have the pets, the ID of the pet, and the ID of the owner, which is probably makes a little bit more sense. But here we could end up doing these joins. So for instance, if we ended up doing this and we ended up doing and I should rephrase this, right? So this is going to give us our inner join, and this is going to give us the users that have pets. Let's just see how they're doing this. We've got our pets. We've got our owners. So select pets and owner's name. From owners, we're inner joining on pets. Right, so the pet actually has the owner ID, right? The owner ID ends up, so the way that we would read this, if we sort of thought about this, is that a pet belongs to an owner. An owner can have multiple pets. But we should also make the distinction that a pet doesn't necessarily have to have an owner, because in fact, we see one of these pets has a null in the table, and that's why when we end up doing this join, we end up getting the pets with the owners, but our lizard ends up getting left out of this table, right? As opposed to doing this where we have our owners and we end up doing a join on our pets, so this will end up giving us all of our owners, okay? So we're doing a left join with our pets. Left join pets. Yeah, I think you're getting all your owners. Let's look at another example here. So here, this actually gives us our, it's a little bit weird. So left join on the pets. Owners, left join. You're getting all the owners.
The left table is owners, right? That's what it is.
Yeah, I don't know. I always end up using outer join, to tell you the truth. Here's an example of a right join. In which case, so you're getting from your owners, you're doing a right join on the pets. So now, what's the difference between these two? Here you've got the owner's name and you've got no pet, okay. And the other one is you have the pets, but you don't have the owner. So again, it depends on which way you're going. I tend to just end up dealing with the first table and doing either a left outer join or right outer join, but you'll get to experiment with this a little bit in the workshop. Sorry, I know that was a crappy explanation. And the outer join is when you end up getting a ton of data, which doesn't make a whole hell of a lot of sense. Although I guess it could. And this might be a little bit of a weird case anyway. In any event, that's the slides. Let me open up the workshop.